Hello and welcome. In this video, we're going to be looking at example 7, which says, find the values of theta in the interval 0 to 2 pi, where the tangent line of r equals 1 minus cosine theta is horizontal or vertical.
Hi, Jay. Thanks for covering for me while I went to the restroom.
Oh, you're welcome.
I'll take it from here.
Okay.
Thanks. Hello and welcome. Oh, yeah, he said that already, didn't he? Let's get started. We can start by writing x equals r cosine theta, where r is 1 minus cosine theta. And then find dx d theta by taking the derivative. Here we're going to use a product rule. First times derivative of second plus the derivative of the first, which would be sine theta, times the second. If we simplify that a little bit, we can distribute the negative sign into the 1 and the cosine. And then we get a couple of sine theta cosine thetas that add together. So we get 2 sine theta cosine theta minus sine theta. That's a pretty simplified version of that. Then over here on the right side, we have y equals r sine theta, where r again is 1 minus cosine theta. So dy d theta is going to be, by the product rule, first times derivative of second, plus the derivative of the first, which is sine theta, times the second, distribute the cosine theta, it's a crazy looking theta. And there we have dy d theta. Now to find dx d theta, we're going to divide those two. But rather than writing out, dy d theta, we're going to divide those two. But rather than writing out dy d theta, remember that if we're looking for horizontal tangent lines, that's going to be where the dy d theta is 0 and the dx d theta is not 0. And vice versa for vertical. So what we're really interested in is where is dy d theta equal to 0 and where is dx d theta equal to 0. Let's first find where dx d theta is equal to 0. We have 2 sine theta cosine theta minus sine theta equals 0. Here we can factor out a sine, and we'll have 2 cosine theta minus 1 left. So we get sine theta equals 0 and cosine theta equals a half. Let's draw a little unit circle so we can show where all the solutions are to both those equations. So sine theta equals 0, that's going to happen when the y value is 0 in the unit circle, which happens at 0 and pi. And then cosine theta equals a half happens at, for the over 3 family, so that's going to be pi over 3 and 5 over 3 in the first and fourth quadrant, because that's where cosine is positive. So then we have dy equals 0. Let's figure out where that happens. Where dy d theta is cosine theta minus cosine squared theta plus squared theta. So where is that equal to 0? This one's a little bit trickier. This is a trig equation. It's a little bit trickier because we don't have anything that we can factor out that's in common. But one of the strategies for solving trig equations is to rewrite all of the trig functions in terms of a single trig function. So in this case, we can rewrite sine squared as 1 minus cosine squared theta. So we have cosine theta minus cosine squared theta plus 1 minus cosine squared theta. And now we have essentially a quadratic in form kind of equation. What we can do is move all of the terms to the right, in which case we'll get 2 cosine squared theta, combining those cosine squared thetas together, minus cosine theta minus 1. This can be factored like any quadratic. If you replace the cosine thetas with 2, you can think about how that resulting trinomial would factor. We're going to have 2 cosine theta plus 1 and then cosine theta minus 1. So there then cosine theta is negative 1/2 and cosine theta is 1. Again, we'll draw a unit circle so we can draw what the solutions are, where the solutions are. Cosine theta equals negative 1/2. That's the over 3 family in the second and the third quadrants, where cosine is negative. So pi over 3 and 4 pi over 3. And then cosine theta equals 1 is right over here at an angle of 0. So now what we can do is make a little table that's going to help us organize things. We're going to make a column for theta, a column for dx d theta, and a column for dy d theta. And then the fourth column that talks about the tangent line. Might need to extend that, I'm not sure. So the theta values that we got are just all the theta values that are solutions to either dx d theta equals 0 or dy d theta equals 0. Those are going to be the key theta values where something might be happening, either a horizontal or a vertical tangent line. So let's write all of those in order. We have 0, pi 3, 2 pi 3, pi, 4 pi over 3, 5 pi over 3. Now we can fill in all the things that we found. We found that with the places where dx d theta are equal to 0 are 0, pi over 3, pi, and 5 pi over 3. So for all those we can put equal to 0, equal to 0, equal to 0, equal to 0, equal to 0. And those are the only places where dx d theta are equal to 0. 0, pi over 3, pi, and 5 pi over 3. At 2 pi over 3 and 4 pi over 3, dx theta is not 0. Otherwise we would have found it when solving the equation dx d theta equals 0. So then dy d theta equals 0 at 0, 2 pi over 3, and 4 pi over 3. And it's not equal to 0 in all the other places. So with this information, we can figure out what the tangent lines are, what type of tangent lines these are. Now the first one is actually the hardest one. If both dy d theta and dx d theta are equal to 0, that's a problem. So we're going to come back to that one. But let's look at when dy d theta is not 0 and dx d theta is 0. Remember that dy dx, so remember that dy dx is dy theta over dx d theta. So when we think, all right, dy d theta is non-zero and dx d theta is 0, that's like dividing by 0, which means we're going to have a vertical tangent line. That's like the infinite slope, that undefined slope is where you have a vertical tangent line. Now, when dy d theta is equal to 0 and dx d theta is not equal to 0, that means the top is 0 and the bottom is not 0. that's just going to equal 0, and you're going to have a horizontal tangent line. At theta equals pi, we have top is not 0, bottom is 0. That's going to make for a vertical tangent line. And then at 4 pi over 3, we have top is 0, bottom is not 0. That's a horizontal tangent line. And then the last one, top is not 0 and the bottom is 0. That's undefined, so that's a vertical tangent. Now the only last remaining case to consider is when theta is equal to 0. Both dy d theta and dx d theta are equal to 0 in that case. So in that case, we're going to come down and figure out what happens. So I'm going to put a little star here. We'll come down below and figure out what the limit as theta approaches 0 is. As theta approaches that theta of 0, where the problem is, of dy, where the slopes of the tangent lines are approaching as at theta approaches 0. Well, dx dx is dy d theta over dx d theta. And dy d theta we said was cosine theta minus cosine squared theta plus sine squared theta over 2 sine theta cosine theta minus cosine theta. So dx d theta was the bottom of the fraction there. Now for this we're going to have to use L'Hopital because this is a type 0 over 0 limit. So we're going to use L'Hopital. Again, because this is a 0 over 0 type limit. L'Hopital says we take the derivative of the top and the derivative of the bottom separately. Let me convert to those derivatives. Derivative of cosine is cosine theta. Derivative of cosine squared theta is going to be 2 cosine theta times negative sine theta. Then the derivative of sine squared theta is 2 sine theta cosine theta. On the bottom, the derivative of 2 sine theta cosine theta, that's going to involve a product rule. So here's the first times the derivative of sine plus the derivative of the first times the second. And then the derivative of cosine, the negative cosine theta there would be positive sine theta. Now that's a big mess, but let's check to see what happens if we plug in theta equals 0 now. We'll get all the sine thetas are 0. So on the top, since each factor has a sine theta, it's going to be 0 on the top. On the bottom, we've got some sine thetas. We've got a couple of cosine thetas that are multiplied together, and those are 1 when theta is 0, right? Cosine 0 is 1. So we have 2 times cosine theta, so that becomes just 2. And then the last term is 0. So this is going to turn into 0 over 2, which is 0. All right, so that says that the slopes of the tangent lines are approaching 0, which means that the tangent lines are looking more and more horizontal. So at theta equals 0, we would say we have a horizontal line. So now we've found the values of theta, where the tangent line is horizontal and where the tangent line is vertical. Thank you for watching, and see you in the next video.